For steps, you've got an ID number. That's expressed as the job ID number, a period, and the step ID number, starting with 0 on the step ID and monotonically increasing. Name, time limit, size specifications, very similar to that for a job. And again, you can specify the nodes to include or exclude from your allocation and node features.
So this gives a general architecture of what a cluster running Slurm would look like, where you've got a Slurm control daemon. You would typically have a backup configured, so if the node that's running the master control daemon fails, you would be able to keep running without any loss of service. There's a database daemon. You might have a backup of that as well, and MySQL database, a single accounting, and that your MySQL database and your that database will have your accounting and configuration records. I'll get into how these daemons interrelate shortly. And if you're running multiple clusters, you would have a single set of tools which you can use to talk to any node in the cluster or any cluster, and those clusters would typically talk to a single database daemon and a single database. So here are your daemons. You've got a control daemon, typically one main one per cluster, with an optional backup. Like I said, it monitors the state of all the resources, it manages the queue of jobs, and it allocates the resources. Basically, this is where almost all of the work happens. On each of the individual compute nodes, you've got a slurmd daemon, and that would launch and manage the user tasks. So when you start your job across multiple nodes, this is what launches those, and it manages the tasks. It's very small and very lightweight, and after you would launch a user application, typically it would go to sleep completely except for optional accounting, and if you do that, it would be synchronized across all the nodes so that all the noise for your job would happen at the same time. And it supports hierarchical communications with a configurable fan out. So back here, those slurmd daemons are all those small boxes on the bottom left, and when they communicate, it uses that hierarchical fan out, which is provides for faster performance. The slurmd daemon is a database manager. There's typically one for an entire enterprise, so for a whole computer center. It collects the accounting information, it uploads configuration information. When an administrator adds users or changes fair share or limits, that information gets pushed out to the appropriate Slurm control daemons on the appropriate clusters. You can configure an optional backup with that, with automatic failover in case your primary node dies. So the daemons have a few common options on your command line. C clears the previous state, purges all your job step partition state information. So if things have gone bad and they're in a bad state, if you use the -C, it'll start you off with a clean slate. -D will run it in the foreground. If you don't run it with that, then it just starts up and you won't see anything at your terminal. It will write the information to the logs, and it becomes a child of the init process. If you run it in the foreground, the output, all the logs are written to standard out right at your terminal. And you can use a -v to print verbose error messages or log messages, and for each V you put on a line, it roughly doubles the volume of messages printed. So in the examples below, you've got three V's or 4 V's, so those are going to print fairly detailed information about what's happening. Without those, it just prints high-level information. I'm starting job X, I'm terminating job Y. With these V's, it's telling you information about the scheduling its decisions that it's making, the communications that's happening, what nodes it's hearing from, and that type of thing. So if you don't know what's happening and you want more information, just adding more V's and running in the foreground is typically the way to get the information you want. If you want to get information about what the compute node has for resources, you can start the SchedMD with a -C option, and it will print out the current information in terms of the number of CPUs, sockets, cores, threads, memory, and temporary disk space. And this can be used as information that you put into the Slurm configuration file. So, for example, if you use this and for whatever reason the node boots and it doesn't have all 6 cores configured, when it registers with the Slurm control daemon, it's going to say, hey, I was expecting 6 cores, you've got 5, I'm going to configure this node down and let sysadmin investigate the problem and fix it before we start running user jobs out there that are expecting 6 cores but only finding 5. There's another program that's not really a Slurm daemon, but it's started up to shepherd each job step. It's called the slurmstepd. It's started by the SchedMD at job step initiation, and that's what manages the job step, its processes, and all the IO. And as soon as the job step terminates, that slurmstepd goes away as well. I'm going to go into the commands here. So there are man pages available for all the commands. Here's some general information about the Slurm commands. There are man pages available for all the commands, all the daemons, and all the configuration files. If you execute one of the Slurm commands with --help on the execute line, it will print a brief description of all of the options, and --usage will print a list of the options. It'll be far more brief. So if you want detailed information, you want to look at the man pages, but if you just need a little hint, --help or --usage might be able to give you the information that you need. The commands can typically be run on any node in the cluster. So if there's a login node, you can run them from there. If you've got an application running, you can on a compute node, then you can run the commands there as well. If any of the commands has a failure, you'll get a non-zero exit code from the program, and there are APIs that the commands use. There are man pages available for all the APIs, and all the Slurm commands use these APIs. So if you wanted to write your own application, you've got all the documentation you need. Almost all of the command options have 2 formats. One is a single letter option. So for example, -p debug for partition debug, and a more verbose option, --partition equals debug. So you can use either one. You can interchange them. It's just if you want the shorthand mechanism and you remember the code, that'll work just fine. The time format that we use is days-hours:minutes:seconds. And like the daemons, the commands have -v options available to print more verbose information about what's happening. Many environment variables are available, so that, for example, if you want to establish default partitions for all your users at your site, you could set up sbatch_partition equals whatever is an environment variable, and that's what they will get as the default, which they can override by what's on the command line.